Hi, we meet again for lecture 2, Introduction to Digital Logic. So I will give you a brief introduction about the logic gate. So logic gate includes NOT gate. NOT gate is known as inverter, where it just look like this. If you give A, it will invert all the information A to A bar. So if you give 1, the output will be 0. So after that, you have AND gate. AND gate, you can have AND gate for 2 input, for example, A and B. AND gate perform the operation of multiply. So it will give you the output AB. If you have AND gate 3 input, A, B, C, for example, you will get A, B, C as the output. And if you have 4 input AND gate, A, B, C, and D, so the output will be A times B times C times D. Next is OR gate. How OR gates look like? OR gates look like this. So you have A, B, for example. This one OR gate for 2 input. So it's perform the operation of plus A plus B. So if you have OR for 3 input, A, B, and C, so you will get A plus B plus C. So same goes to OR gate for 4 input, A, B, C, D. Then you will get A plus B plus C plus D. Next is for NAND gate. NAND gate is just look like AND gate, but it have a bubble after that. So for example, if you have A, B, so it will perform the operation of multiply A, B, and then this bubble represent bar. Bar for all A, B. Same goes to NAND gate for 3 input, A, B, C. So you will get A times B times C bar. So for the NAND gate 4 input, 1, 2, 3, 4, A, B, C, D, bubble. And then you get A times B times C times D, bar. Okay, for NOR gate. NOR gate, it just look like OR gate and have a bubble after that. So let's see the example for 2 input NOR gate. AB perform the operation of A plus B and invert them. So this bubble will invert the operation of A plus B. So this one is NOR gate for 3 input, A, B, C. So A plus B plus C bar. Same goes to NOR gate with 4 input, A, B, C, and D. You will get A plus B plus C plus D bar all. Then XOR and XNOR gate. For the XOR gate, it's perform the operation, it just look like OR gate, like this. Okay, so this one you get AB, for example. So it's become A plus B, like that. So that's one for XOR. So this one represent A bar B plus A B bar. For this one, for XOR. For XNOR, so it just look like XOR, like that. A, B, but it have a bubble after that. So it's perform the operation of A plus in the round B. So this one have bar because this one have bubble. So A plus round B bar become A bar B bar plus A B. Okay. AND gate expressed by dot. OR gate expressed by plus. NOR gate expressed by comma or bar. You can write down A bar or A bar like that. Okay? Okay, next. Let's take a look for logic gate inverter. If you give the input A, it will invert A to A bar as the output. So you see the truth table. If you give 1, the output will be 0. If you give 0, the output will be 1. If you give 1, the output will be 0. So this is the way that you read the timing diagram. So timing diagram, you can draw like this. Okay. If the input is 0, so the output is 1. If the input is 1, the output is 0. Same goes here, 0 to 1, 1 to 0, 0 to 1. This is the way how you read the timing diagram for NOT gate. NOT gate example is perform the operation of first complement. For example, you have input 1, 1, 0, 1, 0, 0, 0, 1. So the output will be 0, 0, 1, 0, 1, 1, 1, 0. You are good? Okay. Next, we move to OR gate. How to see the truth table and timing diagram for OR gate. OR gate perform the operation of plus. If you give the input A, B, two input logic, A plus B. So the output will be A plus B. So if you look at the truth table, if the input is 0, 0, A 0, B 0, 0 plus 0 is 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 is 1. So if you know this, you can read the timing diagram. 0 plus 0 is 0. Okay, this one is 1, this one is 0. 1 plus 0 is 1. 1 plus 1 is 1. 0 plus 1, 1. 0 plus 0, 0. 1 plus 0, 1. 1 plus 1, 1. 0, 1. 0 plus 1 is 1. So you can read this timing diagram in a correct way. Let's take a look for OR gate. OR gate, this is example for OR gate 2 input, 3 input, and 4 input. Now is AND gate. AND gate perform the operation of multiply. So if you have input A and B, so the output will be X equals to A times B. So let's take a look for truth table and timing diagram. For truth table, 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. You are good? Okay, then we move to timing diagram. So look at timing diagram. Input 0, A0, B0. 0 times 0 is 0. 0 times 0, 0. 1 times 0, 0. 1 times 1, 1. Okay, this one is 0, this one is 1. 0 times 1 is 0. 0 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. 0 times 1 is 0. So, this is the way that we read the timing diagram for AND gate. Next, NAND gate. This is example for 2 input AND gate, 3 input AND gate, and 4 input AND gate. This is NAND gate. NAND gate is perform the operation of multiply and bar. Means that it will invert the operation of A times B and then invert it. So you have A times B and then invert all. If you look at the truth table, 0 times 0 is 0. So if you invert 0, it's become 1. 0 times 1 is 0. Invert become 1. 1 times 0 is 0. Invert become 1. 1 times 1 is 1. When you invert, it's become 0. So from all this information from this truth table, you can read the timing diagram over here. So if you have 0, 0, so look here. 0, 0 is 1. 0 times 0, 0, invert 1. 1, 0. 1, 0 is 1. Okay, 1, 0 is 1. 1, 1 is 0. 0, 1 is 1. 0, 0 is 1. 1, 0 is 1. 1, 1 is become 0. 0, 1 is become 1. Okay, this is the way to read the timing diagram for NAND gate. Next, we move to NOR gate. NOR gates perform the operation of plus and it will invert the answer. 0 plus 0 is 0. Invert become 1. 0 plus 1 is 1. Invert become 0. 1 plus 0 is 1. Invert become 0. 1 plus 1 is 1. You invert, become 0. Okay. That's the truth table for NOR gate. So for the timing diagram, you see 0, 0. 0 plus 0 bar 1. 1 plus 0, 0. 1 plus 1 bar 0. 0 plus 1, 1. Invert become 0. 0 plus 0 is 0. Invert become 1. 1 plus 0 is 1. Invert become 0. 1 plus 1 is 1. Invert become 0. 0 plus 1 is 1. Invert become 0. So this is the way that you read for NOR gate. So you settle the timing diagram for NOR gate. Next, we move to exclusive OR or XOR gate. For the XOR gate, you have the input A, B. So if we do the operation of A plus in the bubble B. So it's become A bar B plus A B bar. Like this. So the way that you read to table, so it's quite, you have to put like this. You can do to understand the output. you can do A bar B. This one you can do A B bar. So A bar B, so 1 times 0 is 0. A B bar. A is 0, B is 1. 0 times 1 is 0. Okay, so this one supposed to be the output. Okay. Next, 0, 1. If A bar, so 1. 1 plus 1 is 1. Okay. A B bar. A is 0, B is 1. 1 B bar is 0. 0 plus 0 is 0. A, for the input 1, 0. A bar B is 0 plus 0, 0. A B bar. 1 plus 1, 1. Okay. For A B bar, for the input 1, 1. 0 times 1 is 0. A B bar. A B bar, which is A is 1, B is 0. 1 times 0 is 0. So you can do the plus operation. 0 plus 0 is 0, which is 0. 1 plus 0 is 1, so 1. 0 plus 1 is 1, 1. 0 plus 0 is 0. So that's why you got the answer like this. So you have to do the operation of A bar B plus A B bar. So from here, you read the timing diagram. You can see this timing diagram from the truth table. 0, 1. 0, 0. Okay, if you have the 0, 0, the output will be 0. 1, 0. 1, 0, the output will be 1. 1, 1. 1, 1 will be 0. 0, 1 will be 1. 0, 0 will be 0. 1, 0 will be 1. 1, 1 will be 0. 0, 1 will be 1. Okay, hope that you are good with the exclusive, or we know that as this gate as XOR. Next is the gate exclusive NOR. No, or you can say that XNOR. XNOR gate. XNOR gate, A plus in the round B bar. So it's become A bar B bar plus AB. Okay. So it's become A bar B bar plus AB. So if you want to read the truth table, this one is the truth table. So you have to do A bar B bar to understand the output over here. So you can do A bar B bar. This one is A B. A bar B bar means that if you have the input 0, 0, 0, 0 means that you got 1 times 1 is 1. 0 times 0 is 0. Okay. 1, 0. 1 times 0 is 0. 0 times 1 is 0. 0 times 1 is 0. 1 times 0 is 0. 0 times 0 is 0. 1 times 1 is 1. Then you do the operation. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 1 is 1. That's how you get the output for XNOR gate. XNOR gate, this is the simplification. This is the circuit for XNOR gate. XNOR gate for A, so it's become A bar, B, B bar. A bar, B bar. So you got A, B, become A, B. And then going to OR gate. So it's become A bar, B bar plus A, B. Okay, this is example of IC package. So this is example of universality of gates. What is this gate? This is NAND gate. This NAND gate can also perform the other operation if it's considered as universal gate. For example, this one you got A times A bar is become A bar. So if you give the input A, it's become A bar. So it's performed like the inverter operation, which is A become A bar. So next, if you connect the NAND gate in this way, where you have the input A and B, A, B bar, then you go to another NAND gate like that. So it will become A, B bar, bar, double bar. So you will get AB. So it's performed like AND gate. A, B, you got AB. So you can use this gate to perform the operation AND gate as well. Alright. Next, if for example, if you have this gate, A is become A bar, B become B bar. Then it's going to the NAND gate, A bar times B bar, bar all. So it just look like A plus B. Okay, so A plus B is just look like operation of OR gate. A, B, so do the operation plus over here. So the output will be A plus B. This is NOR gate, universal gate for NOR gate. For example, you have A input going to this NOR gate. X equals to A plus A bar all. This one perform the bar all. So it just look like A bar. So it's also performed like inverter A to A bar. Next, if you have the input AB like this and it's connected between these two NOR gate, 1 and 2, 1 and 2. So this one perform the operation of plus A plus B and then the bar all. So you got A plus B double bar. So A plus B double bar. So you got A plus B. So A, B. So just like A plus B normal OR gate. Okay. If NOR gate operates like this, A, B. So you got A bar, B bar. So A bar, B bar. So it's going to this operation. You do the operation of plus and bar all. So we got A, B, A. It's just like A, B. So it's just like AND gate, A, B. So you got A times B. So if you have the IC package like this, for example, in the lab, how do you do the connection? So we can practice. For example, if you want the input Y equals to A B bar plus B bar C bar. So you can do like input A don't have bar, so you can use this one as the input A. B bar, so B bar you can use this one as a B bar. So you can choose which one. This one is B, this one is B bar. So B bar, A bar, B bar. So this one connected to this one. So this one is B bar. So you got A, B bar. So the output number 11 is A, B bar. So next, B bar, C bar. Okay, B bar. So you can connect to B bar. B bar. So you can connect to B bar. B bar. You can connect here. B bar, C bar, C bar. This one this one is C, this one is C bar. So going here, this one is C bar, this one is B bar. So this output over here is B bar, C bar. So these two will go to the operation of plus. So you go A bar B. So A B bar going here. So you got A B bar, B C bar, B bar C bar. So this is the output Y. Okay, that's all for basic logic gate today. Thank you very much for your class today.